Kaitema Frappo and welcome to part 20 of the NatWi grammar course. This is actually the last full part of the series. Afterwards there will be one more video with kind of a summary where we look at every topic very briefly again. And then the grammar course is finished. But there will of course be other videos about random small topics that we haven't covered in the grammar course, and practice stuff and listening exercises and many other things. Today, like you can see, we will talk about numbers. Here's a short overview what we will talk about in particular. First, we will look at some basic number words. We will see how to use them in a sentence. Then we will do some mathematics, because the NatWi use the octal number system while we use the decimal one. If we want to actually learn how to say NatWi numbers on the fly, then we need to learn how to convert our decimal numbers into the NatWi octal numbers. And this is what we will look at in that part of the video. So we'll first talk about what actually is the difference between octal and decimal numbers. We will see how to convert octal numbers into decimal and how to convert decimal into octal numbers. Then we will learn how to form number words from these octal numbers we just created. Lastly, we will also talk about ordinal numbers like first, second, third, and so on. And we will also talk about fractions. So now I know that many people are not really interested in all this mathematics stuff and octal and decimal number systems and so on. And you don't really need it. So if you're one of these people, just look at these. Just skip the middle part. You will learn then how to do basic numbers, like the numbers that you will most likely need in conversations. You will learn how to use them in a sentence. You will learn how to say first, second, and fifth, and so on. And you can also learn about fractions like 1/5, 1/6, 2/5, and so on if you want, but you also don't really need these. So if you really want only the basics and are not interested in numbers at all, like you have nightmares from your time in school for math class, just do these things, ignore the rest. So, like I said, we start with a small section for those people who don't like math. We will look at the basic number words and completely ignore the mathematics behind it. Like I said, you don't really need to learn more. Because if you think about it, in day-to-day conversations, you usually don't use high numbers. You use small numbers that you can just learn by heart if you're talking in NatWi. And then words like many, a few, 100, 1,000. So it's just things that you can easily learn by heart. Here are the first 20 numbers. Like I said, that's something that you just have to learn by heart. So we have au, mune, p'ei, tsing, mrr, pukap, gine, vol, volau, vomun, vopei, vosing, vomr, vofu, vohin, mevol, mevolau, mevomun, mevopei, mevosing. So these are just numbers 1 to 20. You can just learn them by heart. Then if you want to talk, if you want to say stuff like 100 or something or 1,000, in NatWi, you would actually not say exactly 100 or 1,000. We would say zam for 64, vosam for 512, and zazam for 4,096. This is because, like I said, in NatWi use the octal number system. So basically for them, the 64 is like for us the 100. The 5012 in octal is basically like for us the 1,000. Like these are the round numbers for the NatWi. If you want to say more figuratively that you have like a lot of something, then you would not say, I have 1,000 of something. In NatWi, you would basically say, oh, I have vosam of something, because that's a round number for the NatWi. And here's some other helpful words. Many you can say with I. A few of something would be whole. And we also have 0, which is keo. Using numbers in sentences is very simple, and you should probably already know how to do that, because numbers are just adjectives. So for example, CA, well, wola, jerigit, I see 8 jerigs. And now you can also put after the jerigs, of course, CA, well, jerigit, avol. It means the same, I see 8 jerigs. What you maybe noticed here is that I say jerigit and not I jerigit. So I use the singular form here, While in English I say jährigs instead of jährig. In English we use the plural. In NATVI we don't need to do that. If there is already a number word that tells us that there are many of something, then we can just use the singular form. The same also goes for words like I, many, that you learned on the slide before. So I could also say CA well jährigit. I see many-jährig. So in English, many-jährigs with the plural form. In NATVI, jährig in the singular form. You can also say something like Polaum tate baumit ado amr. I asked that question 5 times. So ado means a time, like time, instance of something. Ado amr 5 times. And also the ordinal number, so second in this case, work the same way. Leut amuve well zwola. I forgot the second word. That was it with the basic overview over the first 3 numbers and how to use them in a sentence. Let's do some math. So if you're not interested in all that stuff, then you can just now jump to the end. In case you're still here, let's do some mathematics. The decimal system. Like I said, in NATVI we use the octal system, but before we talk about what exactly it is, we should talk about what our own system is or what it means to have a decimal system. Let's take this number, 143. If we look at it in detail, then actually we see it is 3 times 1, plus 4 times 10, plus 1 times 100. Why is it that way? Because we have the base 10. So the last digit is worth 3 times 1 because it's 10 to the power of 0, which everything to the power of 0 is always 1. Then 4 times 10, the second digit from behind, is 10 to the power of 1 worth times 4. And next, if we go 1 higher, we get 10 squared, which is 100, which is why the first digit in this case is worth 1 times 100. So we put that all together and we get, who would have thought, 143. Let's do it with a bit larger number. 2735. It's 5 times 1, plus 3 times 10, plus 7 times 100, plus 2 times 1000, because the next higher thing would then be 10 to the power of 3, which is 1000. And who would have thought we again get the same number? Now the octal system is a bit different. Let's look at the same numbers, but in the octal system. So we again start with the 143, but in octal. The first thing doesn't really change, 3 times 1, but suddenly we have 4 times 8. And then we get 1 times 64. And if we put that together, if we do the maths here and make 1 times 64 plus 4 times 8 plus 3 times 1, we suddenly get a completely different number, namely the 99. What does that mean? It means that the octal number 143 is 99 in the decimal system. So these two numbers, the octal number 143 and the decimal number 99, are basically the same. They are worth the same thing. If I see 99 sheep in front of me, then I could also say, yeah, in octal, that's 143 sheep, but in decimal, it's 99 sheep. So it's the same amount of sheep, just basically 2 different languages that have 2 different words for the same number. The same for the 2735. 5 times 1, that's still the same, plus 3 times 8, plus 7 times 64, and then 2 times 512. And if we put it all together, we get 1501 in decimal. So what's the difference here? I guess you could already spot it. The base changes. So the 10 changed into an 8. 8 to the power of 0 still is 1. 8 to the power of 1 obviously is 8. Then 8 to the power of 2, or 8 squared, is 64, which is why we don't have 100 here, but 64. And 8 to the power of 3 is 512. That's why we have 2 times 512 and not 2 times 1000. So that is what it means that it is an octal system. It uses the base of 8 instead of the base of 10 that the decimal system uses. Let's look at some other examples. If we have the octal number 23, then what that actually means is that we have 2 times 8 plus 3 times 1, so we get 19 in decimal. 12 in octal would be 1 times 8, because we start with a 1, plus 2 times 1, which is 10 in decimal. If we take 35 in octal, then we have 3 times 8 plus 5 times 1, which is 29. So it means that the octal number 35 is 29 in decimal. And 100 in octal would be 1 times 64 plus 0 times 8 plus 0 times 1, so it would be 64 decimal. This is why earlier I showed you the word for 64, sum, because for the NATVI, 64 is a round number, because in octal it's 100. It still is worth 64 in decimals. So if I say I have samajährig, then I have 64-jährig, but in octal, basically in the octal language, it would be 100-jährig, because 100 octal is 64 decimal. And now you already learned how to convert octal numbers into decimal numbers. Namely, you just have to take them apart, do the maths, like for 23, put together the 3 times 8 plus 3 times 1, and then the result gets you the decimal number, in this case 19. Now, of course, we want to do the other way around. We want to say something in NATVI, so we need to get our English number, our decimal number, converted into octal. Let's look at some ways how to do this. Let's start with the 100, so decimal number 100. We can simply always divide by 8. 100 through 8 is 12 with a remainder of 4. Note that we here work with a remainder, so we don't do 12.5, we say 12 with a remainder of 4. Then we take the 12 and continue with that one. 12 divided by 8 is 1 with a remainder of 4. We then go on again with the 1. 1 divided by 8 is 0 with a remainder of 1. What we now do is we take these remainders from the bottom to the top, and that is our octal number. So 100 decimal converts to 144 in octal. Let's look at another example. 123. Again, we start with our decimal number. 123 divided by 8 is 15, remainder 3. We go on with the 15. 15 divided by 8 is 1 with a remainder of 7. 1 divided by 8 is 0 with a remainder of 1. We again take our remainders from bottom to top, so we get 173 as our octal number. Now we can also do it a bit differently. It is in principle the same thing, but just we think differently about it. And for some people that don't really do maths that often, that is easier, I heard. We start again for our 100, and then we just think about, does 512 fit into 100? No, it doesn't, so we ignore it. We go on to the next lower one we have, which is the 64. 64 fits one time into 100. That's great. What we now know is that the number starts with a 1, because we just established 64 fits 1 times into 100. So basically the digit that is worth 64 needs to have a 1 there, right? Because we have 1 times 64. We now go on with the 36. Why? Because our number is 100. We already kind of used up 64 of it, because we have a 1 on the 64 digit. So we are left with 36. 8 fits 4 times into 36. So we know our next digit must be a 4. So our number starts with 1, 4. We go on with 36 minus 32 because we used 4 times 8, so 32, and we are left with 4. 1 fits 4 times into 4 because it's 4. And with that we know that the number is 144 in octal. And this is, if you remember it, the same we had before. So 144 in octal is 100 in decimal. 123 is our second example. 512 again doesn't fit, so we ignore it. 64 again fits 1 time. Number starts with 1, and we go on with 59, because if we take 123 minus 64, we get 59. 8 fits 7 times into 59, so the next digit must be a 7, where we get the number that starts with 1, 7. We go on with 3. 1 fits 3 times into 3, so we know our number must end with a 3. So it's 173 in octal, which is 123 in decimal. Let's look at some more examples. 64 decimal we already established before that 64 is in decimal, translates to 100 in octal. So let's look if our methods here work and actually give us that result. 512 doesn't fit into 100, so we ignore it. 64 fits 1 times into 64. So we know our number starts with 1. We go on with 0 because 64 minus 64 is 0. Even though we have 0, we don't stop. We go on with the next lower number. 8 fits 0 times into 0. So the next digit is 0, so we start with 1, 0. Again, 1 fits 0 times into 0, so we know that our number must be 100 because 1, 0, 0. So 100 in octal is 64 in decimal. Let's do the other method. If we divide 64 by 8, we get 8 with a remainder of 0 because 8 times 8 is 64. We go on with the 8. 8 divided by 8 is 1 with a remainder of 0. We go on with the 1. 1 divided by 8 is 0 with a remainder of 1. Again, if we take it from bottom to top, we get 100 octal. So it actually works, isn't that great? Now you might be thinking, why am I doing all this nonsense? Why do we need math for this? For that, let's look again at English first and at the decimal system. We use decimal numbers as base for our number words. So for example, let's look at 145. I mean, the word already says it all. 100, because we have the digit 1 at the place for hundreds. 40, because we have the 4 at the place for the 10 digits. And 5, because we have the 5 at the end, so at the digit place that is worth 1. So basically we say 1 times 100, 4 times 10, and 5. Or 1234. We say literally that, 1 times 1000, so 1234. And yeah, the NATVI do actually the same, but they use the octal number as the base. So, as an example, if I take again the 145, the NATVI would read this as 1 times 64, 4 times 8, and 5. If you do the maths here, then you probably can see that this is a different number, so they see, for them, this is 101 in decimal. So, if we want to build our number words, we first have to convert the number, our decimal number, into an octal number so we can use that as the base for the number words. How are we doing this? You already learned the basic words for the first few numbers on the first slide. I repeat them again. We have au, mune, p'e, tsing, mr, buka, p'kine, and vol. So these are the first 8 numbers. And vol, 8, of course, for the NATVI is like 10, because it is 1 times 8 plus 0. If we now go on, what we do is we say volau. So basically 8 plus 1, which is 9. For the NATVI, that would be 11, octal number 11, because 1 times 8 plus 1. You can see this word is built from vol, 8, plus au, 1. Same for the next, vomoon, vol plus moon, 8 plus 2. Vopei, vosing, vomr, vofu, vohin, mevol. So here you see mevol would be 2 times 8. So 16, or in octal number 20. We continue exactly like this. So mevolau, 2 times 8 plus 1. Mevomoon, 2 times 8 plus 2, so 18, or in octal 22. Mevopei, 2 times 8 plus 3, so 19, or in octal number 23. Mevosing, mevomr, mevofu, mevohin. And then for the 24, or in octal 30, p'evol, 3 times 8. So you see, it's actually a very regular process. Here you can see again how the numbers words are built together with a simple number with only 2 digits. So I took the 23 here as an example. So mevopei is me, 2 times, vo, 8, plus pei, 3. So 2 times 8 plus 3, which is exactly our octal number here. That was the basic principle. Let's look at all the building blocks we have. Here again, we have our basic numbers, the ones you already know. And then we also have a prefixed form for all of them. Remember from before when we said mevol, 2 times 8 for 20 in octal, or 16 because 2 times 8 in decimal. For au, we don't have any. For mune, so 2 of something, we put me in front, so mevol was the example we had. For a, it becomes e. Then we have c, mr, bu, and ki. We also have a suffixed form. That was, for example, when you remember, if you want to say 17, which becomes 21 in octal, then we want to say 2 times 8 plus 1. So we would say mevo lau. Or also, if I just want to say 9, then I would say 8 plus 1, so vo lau. And this au is one of the suffixed forms. Here you see all of them. Au, moon, bei, sing, mr, fu, and hin. Like you can see, the omission happened here. So we don't have keen, we have hin. We don't have pu, we have fu. Let's look again at some examples now that we have all the building blocks together here. 25 in decimal would become 31 in octal if we use the methods that we learned before. So that would be 3 times 8 plus 1. 3 times 8 would be e vol, because e is our prefix 3 times, vol 8. Plus 1 then would be au, so we get e vo lau as our word for 31 in octal, but this then of course translates to 25 in decimal. Another example, 61 decimal becomes 75 in octal. That would be 7 times 8 plus 5. So 7 times 8 we get ki vol, and then mr for the 5. And now you see something interesting. The L from the vol disappears. This happens in all cases except if the vol is at the end. So for example, if I just say vol, or if I say me vol 2 times 8. Or if the au is there. So you saw before we had e vo lau, there the L stays. But for any other suffix, the L disappears. So we get ki vo mr. Sometimes we want to say higher numbers, so if we have 3-digit numbers. And for these, we can use these. So 64 becomes sam, 512 is vosam, and 4096 is sasam. These are basically our next digits. Let's look at an example. 234 decimal becomes 352 in octal. So that is 3 times 64 plus 5 times 8 plus 2. And now we just do exactly the same like before. We just incorporate the 64 in there. So we get this. 3 times 64, so e sa. Then 5 times 8, mrvo. And then 2, moon. So we use the e prefix with sa, because we have 3 times 64. Then we use the mr prefix with the vo, because we have 5 times 8. And then we use the moon suffix because we end with a 2. So we get esa mrvo moon. For the sam, actually the same happens as for the vol. So the m disappears if we don't have samau, so 64 plus 1, or if the sam is not at the end. The same also happens for the vosam and the sasam respectively. Next, let's look at the ordinal numbers, which can be built with the suffix v. So ordinal numbers are things like first, second, third, fourth, and so on. Au, 1, would become auve, first. Mune, 2, would become muve, second. A, 3, would become ave, third. Tsing, 4, would become tseve, fourth. Mr, 5, would become mrve, fifth. Bukab, 6, becomes puve, sixth. Kine, 7, would become kive, seventh. And vol, 8, would become volve, eighth. So we just add the v at the end and use again shortened forms. If we are using the suffix forms, something similar happens. So it would be auve, muve, beive, seve, mrve, vuve, hive, and volve. So basically it's the same as we had before. With our suffix forms, we just add the v at the end. Let's look at an example again. So evohin, 31 in decimal, 37 in octal, would become evohive, 31st. For higher numbers, again, we have also forms for sam, sasam, and wosam. So sam would become save, wosa would become wosave. Here, very interesting, the stress shifts from wosam to wosave, and sasam would become sasave. Let's look at some examples. Again, the sentence we already heard before. Le ud amuve, welzwilla. I forgot the second word. So you see, they're used exactly like the other numbers, like adjectives. Alu a auve, olzau van soli. I played that game for the first time. Murvea terol, verosunu frato. I like the fifth song the most. And, very interesting, we can actually also make them into adverbs with ne. So, ne auve, kolen, ne gilvan. First, we went to the river. Ne auve is in the dictionary, but we can actually also do that with any other of these numbers. So we can say, tera nemfa natring, ne move. Secondly, we walked into the forest. Lastly, let's look at fractions, so stuff like a half, a third, a fourth of something, a fifth of something, and so on. And for that, we just replace the ve with the pe suffix. For half and third, we actually have own words, so they work a bit different. A half would be maul, a third of something would be pan. But from there on, we just replace it with pe, like I said. So cve was the fourth something. If we want to say a fourth, like the fraction a fourth of something, we would say cpe. A fifth of something would be mrpe. Then we have pupe, kipe, and wope. Note that the stress here shifts to the pe suffix. And we can also build higher fractions, so stuff like 2/4 or something, by just adding an adjective to it. So tsinga mrpe would be 4/5, because tsing is 4, tsinga mrpe 4/5. Keep e up a 3/7. Munea mrpe 2/5. Now you might be asking maybe, why don't I just say me mrpe? Because usually I can use me as a prefix to say 2 of something. So let's compare the next two things. Munea wope would be 2/8. If I would here use me instead, then I would get this, me wope, which would mean 1/16, because me vol is 16, 2 times 8. So me wope would be 1/16. And because of this, when we are talking about fractions, we actually need to use mune and pe as full numbers instead of the forms me and pe that we learned for other nouns. One exception to this is actually mefan, 2/3. That is just a special form that exists that way. So mefan, but for all the others, munea, How do you use them in sentences? Like I already said, there are nouns. So all the other number words we had were adjectives. This time we have nouns, which means they can get case endings. Neo vel munia mrp eti. I want 2/5. Here you see the mrp eti got the T ending, because what do I want? The 2/5. Nantange zip eti vel rolun. I found a fourth of the nantangs. So you see, it's pretty straightforward. Just don't forget your case endings when working with these words. Since we're already talking about pe, I want to show you where it actually comes from. Namely, hab e is a noun which means a part of something, and there are also a few other useful words that are built with that. So we have, for example, amp e, majority, most, or large part. Or we have himp e, minority, least, small part. There are a few other words that are built with this. For example, we also have swap e for a family member. So basically a e of a family. So I just added these words here to show you that once you know a small part of the Natvi language, you will also find them in many other parts. So you will see them again and again. So learning vocab will actually be easier and easier with time. Lastly, I want to talk about 8 and 9. Maybe you can already hear it. 8 sounds a bit like 8 in English. 9 sounds exactly like 9 in English. So the numbers 8 and 9. And these are words in the Natvi language. So 8 is 8, but it is the symbol 8. So which the Sky people use. It is not the number, the value 8. It is really only the symbol 8. Same as for 9. 9 describes the sign or the symbol 9, which the Sky people use, not the number. We used it, for example, for telephone numbers or stuff like that. So when we really needed digits 8 and 9. So this is why they have been loaned into the NATVI language, but they're really only for us to talk about stuff like telephone numbers. If you talk about actual values and numbers in the NATVI language, avoid them as best as possible because the NATVI don't really have a concept for that. And that was it. If you have any questions, then like always you can ask in the comments or contact me on Discord. Like I said, this is the last video, or this is the last full video of the grammar series. There will be the summary video, but if there's anything that you are missing, like if there are any grammar topics you are missing, you can always write in the comments or just write me on Discord. Because there will be more videos, it will just be smaller grammar videos about smaller topics, and then completely different videos where we analyze stuff, where we look at examples, where we look at idioms and stuff like that. So if while watching the series you felt like some grammar topic is missing, just contact me and I will make a small video about it. Hi, Yellow Frappo.